Hey guys, welcome back to MathMads YouTube channel. Let's look at some short answer type in arithmetic progression. First one, write the nth term of, they have given an AP and we have to write the nth term. So what is nth term formula? An is equal to a plus n minus 1 into d. So to write the nth term, I need the first term, I need the common difference. So I know the first term is 1 by m, right? This is a. Now, how will I find the common difference? I just have to take the difference of the second term and the first term. So, d is equal to 1 plus m by m, that is second term, minus the first term, that is 1 by m. Okay. So, now here I can split this fraction further. 1 by m plus m by m, that is 1, minus 1 by m. So, 1 by m and minus 1 by m gets cancelled. So, what is d? Common difference is 1. Now just substitute this in the formula. So an will be equal to first term, that is 1 by m plus n minus 1 into d. D is 1. So this, if I multiply it, I'll get 1 by m plus n minus 1. That's it. So this is the nth term. Now let's look at the second one. If 5 times the fifth term of an AP is equal to 8 times its eighth term, show that its 13th term is 0. Very simple. 5 times the fifth term of an AP. So that is A5 is equal to 8 times the eighth term. That is 8 times the eighth term. Okay. So let's apply the general term formula, that is A plus n minus 1 into d. So 5 into A plus n minus 1. Since your n is 5, it will be 4d is equal to 8 into again a plus n minus 1, that is 7d. So let me multiply this. 5a plus 20d is equal to 8a plus 56d. Now let me bring a on one side and d on other side. So I'll have 5a minus 8a is equal to 56d minus 20d. That is minus 3a is equal to 36d. So a will be equal to minus 12d. So that is the relation between a and d. But what am I supposed to show? That 13th term is 0. So what is 13th term? A13 is equal to a plus n minus 1. That is 13 minus 1. That is 12d. But I know that a is equal to minus 12d. So substitute it. Minus 12d plus 12d. They get cancelled and you get a13 is equal to 0. Hence proved. Now let's look at the third problem. This is a very typical question. Okay. Find the sum of first 10 multiples of 5. So they can give you find the sum of first 8 multiples of 8 or something like that. Okay. So now let's look at how to tackle this problem. They have given first 10 multiples. That means n is equal to 10. Okay. And then they've given of 5. That means the common difference will be 5. Because if you take the multiples of 5, how do they start? 5, then 5 2s are 10, then 15, 20 and so on. So you can observe that the common difference is 5. So whichever multiplication table that they've given, just take that as the common difference. And that itself will be the first term also. So a will be equal to 5. I have to find the sum of first 10 multiples. So I am supposed to use Sn is equal to n by 2 into 2a plus n minus 1 into d. I can either use this formula or I can use n by 2 into a plus l if you know the last term. Okay, now let me use this. So n is equal to 10. So let me substitute 10 by 2 into 2a. A is 5, so 2a will be 10 plus n minus 1 will be 9 into d is 5. So further this will be 5 into 10 plus 45, that is 55. So 5 into 55 will give you 275. So that is the sum of first 10 multiples of 5. Okay. Now the next one. If the sum of n terms of an AP is 2n square plus 5n, find the fourth term. So this is also a very simple question, but many of you go wrong. They are asking you the fourth term and they've given you the sum of n terms. What is sum of n terms? 2n square plus 5n. Okay. Now, if I want the fourth term, now look at the AP. Let me take A1, A2, A3, A4. Okay, this will give me sum up to 4 terms if I add them up. Okay, and if I take sum up to 3 terms, I'll get A1 plus A2 plus A3. I need to find A4. How will I get A4? A4 will be, if I take the sum up to 4 terms, that is S4, minus, I'll just subtract sum up to 3 terms. Why am I writing the term in terms of the sum? Because I only know the formula for sum. So fourth term is equal to sum up to 4 terms minus sum up to 3 terms. Now you just substitute in place of n as 4 and n as 3. So 2 into 4 square plus 5 into 4. Okay, this is sum up to 4 terms minus sum up to 3 terms. That is 2 into 3 square plus 5 into 3. So 2 into 4 square is 16. So 32 plus 20 minus 9 into 2 is 18 plus 15. So this is 52 minus 33. That will be 19. So fourth term is 19. Now the last question. Show that AP plus AP plus 2Q is equal to 2AP plus Q for an AP. So whenever they give like this, it means a pth term and this is p plus 2qth term. Generally, we know an is equal to a plus n minus 1 into d. So if I take the left hand side here, LHS is equal to ap plus ap plus 2q. So let me substitute p and p plus 2q in place of n. What will I get? A plus p minus 1 into d plus, now for a plus a p plus 2q, what will I get? A plus p plus 2q minus 1 into d, right? So I've just substituted in the general term now. Here I can take a plus a, I'll get 2a. Now if I take d common from these two, what will I get? P minus 1 plus p plus 2q minus 1 into d, that is common. Further 2a plus, here I can simplify inside the bracket, I'll get 2p plus 2q minus 1 I'll get minus 2 into d. I can take 2 common from both the terms. What will I be left with? 2 into, from here I'll be left with a plus, here I've taken 2 common. So what will I be left with? P plus q minus 1 into d. Now, if you take p plus q as one entity, I can write this as a p plus qth term. So, 2a p plus q. So, this is our RHS. AP plus AP plus 2q is equal to this. This is our RHS and we have proved it.